This video is recorded to help my students to understand normal distribution and the basic calculation related to the normal distribution. We start from the standard normal distribution. Standard normal distribution is a probability distribution with mean equal to 0 and standard deviation equal to 1. And the total area under its density curve is equal to 1. The picture looks like this. So you notice that mean is always in the center of this picture, and the scale is the standard deviation. There are two kinds of calculation involved with standard normal distribution. One is given z-score, calculate related probability. We have three cases here. One is given z-score, calculate probability that the random pickup z value is less than this given z-score A. So picture look like this. The formula you use is normal.s.distribution A true. This true means you want the accumulative, okay, which means calculate all the area on the left side of A. Now, for example, if your A is 1.58, so PZ less than 1.58, which means I want to calculate the probability for random pickup of this score that is less than 1.58. So the formula we use is this normal.s.distribution 1.8 true. Now this true can be replaced by 1. 1 means true, true means 1 in this case. Now, second case is you want to calculate probability for random pickup of z-score is greater than a given z-score A. Now, like this picture, suppose your A is negative 1.23. So I want to find the probability for random pickup z-score is greater than negative 1.23. Equivalent where I want to find the area of this shadow part. Now, there is no formula directly to calculate this, so we will use 1 minus the area on his left side because we have formula to do that, and we know the total area is 1, so I use 1 minus the left side 1. So the formula used is 1 minus normal.s.distribution A true. Again, true is accumulative. So for this particular example, P probability of z greater than negative 1.23, you will use the formula like this, 1 minus normal.s.distribution negative 1.23 true. Okay. Now, case 3 is I want to calculate the probability for random pickup z-score will locate between two given values. Now, for this example, if you use left value is negative 2.0, right value is 1.5, so equivalently you want to find the area between negative 2 and 1.5. Now, in order to calculate this area, I will use this odd area on the left side of 1.5 minus the area on the left side of 1.5, or the area on the left side of 1.5 minus the area on the left side of negative 2. So the area on the left side of 1.5 is normal.s dot distribution 1.51. We said 1 means 2. The area on the left side of negative 2 is normal.s dot distribution negative 2, 1. So we use this to subtract, then we got the area in between. Okay, this is the first calculation. Given z-score, you calculate a related probability. The second calculation is if I give a probability, you need to be able to calculate the corresponding z-score. For example, if I know the probability on the left side of this z-score is 0.95, then what is this z-score? Okay, so the calculation is use normal.s.inverse. Then you give me the area, give this function the area on the left side of this z-score. This will return you the value of this z-score, which is 1.6648485. Now, second case, if you know the area on the right side of z-score, for example, I know this area is 0.025. Now, then if I know this is 0.025, then I know the area on its left side is 1 minus 0.025, right? So which means if I know the area on the right side of the z-score is alpha, then the area on the left side of the z-score is 1 minus alpha. So the formula to use here is equal normal dot s dot inverse 1 minus alpha. Now for this example, I want you calculate the corresponding to these scores. One is on the left side area is 0.025. Another is this score for the right side area for the z equals 0.025. For the left side one, you directly use 0.025 because the formula is calculated, right? The corresponding z-score such that the area on the left side is the given value. However, for the right side one, he gave you this tail value, so you need to use 1 minus this tail value to get the area on its left side. So the formula used is this, normal dot s dot inverse 1 minus 0.025. Okay? So we studied the standard normal distribution. Now, how about a line standard normal distribution? Again, its curve still bell-shaped and symmetric, and the center is the mean. Okay, there are two ways to handle the calculation. Method one, you first convert the x value to the corresponding z-score, which means you convert the line standard normal distribution to the standard normal distribution case. The conversion, you can do this, formula is this. Z-score equal x minus mu divided by sigma, where mu is the mean, sigma is the population standard deviation. So x is the random value. Now, equivalent, if I want to know what is the probability for random pickup value were less than this given x. Now, by this conversion, I change it to what is the probability that a random pickup z-score were less than this given z-score. Okay, those two probabilities are the same. So the two ways to do this, right? As I said, first you can calculate the first method is calculate the corresponding z-score. So in this case, let's say the mu is 100. For example, mu is 170 and the sigma is 18. Now I want to calculate probability for a random pickup x is greater than 175. How much is that? Now, the calculation is that we first want list out what is x. Okay, x equal 175. Then what is mu? Mu equal 170. What is sigma? Sigma is 18. So what is z? Z will equal, you can type the formula x, which is h23. I should type equal first. h23 minus mu, which is h19, then divide by sigma, which is h20. Okay, that's your z-score. So after this z-score, again, now we convert it to standard normal distribution case, right? So then we will find that p z is greater than this z-score 27778. That will equal what? Now the previous few minutes ago we just studied this. This will equal 1 minus the normal distribution, normal dot s dot distribution. You give me a z-score. Z-score is located in h24, and I want a cumulative. So I got this is the probability. Okay, for random pickup, z-score is greater than 0.2778. Okay. Now, but there is another way to calculate this z-score. The Excel gave you a formula. This formula is called standardized ST. Okay, you type ST, he already automatically give you hint. Now, then this will give you x. Your x is 175. Mean mean, well, I type in cell, X is in H23, 175. Your mean is in H19, okay? Your sigma standard deviation is in H20, okay? Now, you should get the exact same thing, okay? So you say you have two ways to calculate Z. One way you type this formula by yourself. Another way is you use Excel built-in formula called standardized to calculate this score. Then you convert non-standard normal distribution problem to a standard normal distribution problem. So the probability for X greater than 175 will equivalent to the probability for Z greater than 0.277778. This one way. Actually, Excel provides another way, an easy way to do this. You do not need to do any conversion. You just need to use different Excel formula. You can just simply use 1 minus norm dot distribution. Pay attention. This time you do not have dot S. That means it's not a standard normal distribution. When you type this, Excel give you a hint. You first need to give him value X. Your X value is in H23. Then you need to give him a value of mean, mu, which is in H19. Then you need to give him the value of standard deviation, which is in H20. Now, then you need to tell him it's accumulative, it's 1, or you type true there. Now, you say you got exactly the same answer. So, for the line standard normal distribution, you have two ways to do the related calculation. One is use this formula to convert it to standard normal distribution, then use whatever we studied before. Another is directly use this Excel built-in formula, normal data distribution. This one have 4 arguments. You give him X value, mean value, standard deviation value, and of course this is always true. Okay, now let's use the analogy we studied to see some examples. The application. Example 1. Assume that adults have IQ score that are normally distributed with mean 105 and standard deviation 15. Find the probability that a randomly selected adult has IQ score between 95 and 118. So we know the mu, we know the sigma. Now we need to calculate the probability for the random select IQ score is between 95 and 119. Based on the knowledge we studied before, we know you need to calculate the area between two given values. So we will use norm dot distribution. So one X value is 118, the mean is 105, and the sigma is 15, and I want the accumulative. So this formula calculates the area on the left side of 118. Then you need to minus this area on the left side of 95. So 95, then the mean is 105, and the sigma is 15, and the cumulative. Okay. Of course, you can always change this 105 to the cell number and this 15 to the cell number. Okay. So, which means what? 55.44% adults, their IQ score is between 95 and 118, or you say random select adult, his IQ score between 95 and 118, you have 55.44 chance to get that. Now, then with the same assumption from example 1, find the IQ score that separate bottom 10% from the top 90%. Equivalently, you need to find A such that probability for X less than A is 0.1. So in this case, I will use norm dot inverse. Now he asks you for probability is 0.1, and the mean is 105, and standard deviation is 15. So this gives you 85.77. This means for the IQ score is less than 85.77, those are the bottom 10%. If you have any questions, please give me an email.